Our second panel is more technical than the first one, I believe. And this one is going to tackle the needs for infrastructure. How is AI going to be consumed? How is it going to be delivered? And what is the infrastructure that will be required, essentially, to deliver on that? This panel is going to be moderated by Olga Orda, who is the Vice President of Marketing for Digamma. And we have a distinguished panelist of four guys that will introduce themselves: Doug, Prateek, Christian, and Gus. And I will leave it to you to kick it off.
Okay, thank you, Najib. So as Najib mentioned, my name is Olga. I'll be the moderator for this technical panel. I work at Digamma. We are machine learning consultants based here in the Bay Area. We've been engineering, architecting machine learning solutions for startups and enterprises for the past 13 years. Come up to me, Olga, then at the panel if you have any questions. And also we have our leadership team, Vadim and Alex, sitting there in the front row, so they'll just be waving. So with no further ado, we'll have all the panelists introduce themselves briefly. I think we have some really interesting people here in this room. So we'll start with Doug first.
Cool, nice. So I'm Doug. So let's see, I've done a lot of different things. I did study computer science and psychology and turned that into a PhD in cognitive neuroscience and language. But I end up here because right now I'm running Newbery Labs. And so Newbery Labs is an evolution of a company called Geometric Intelligence. So it's a company I co-founded with a bunch of professors in machine learning. So Gary Marcus, a guy named Zubin Garamani, who's from Cambridge, UK. And so I guess, not to take up too much time, but very briefly, we do a lot of different things. We do machine learning research. So we were academics, and we actually specialize in things that are not deep learning, so kind of augmented deep learning. And so I was talking to you briefly about where we're going next. We're going somewhere else that's not deep learning, to be on the front of that. So we were a bunch of academics, but no place to apply our knowledge, and so we were looking for and we found that a lot of different places to apply. And so it's very interesting last 9 months. We got like a lot for there. So happy to talk about that. Some of the interesting parts of that, though, is trying to meld research and application. And so Uber is super interesting because it operates at scale, but also very quickly. And so there's very little friction in between research and application at Uber, which has been fun. So I kind of try and make that work.
Cool. I am Prateek, founder of Pluto AI. My field of expertise is artificial intelligence, and I've published 8 books on the topic, including an Amazon top 10 bestseller. I've worked on different aspects of AI, like self-driving cars, image recognition, sensor data. And at Pluto right now, we are building an intelligence platform for water plants, the most precious resource on our planet. And in the past, I worked at different companies, including NVIDIA, which is, when I was there, it was a company building GPUs. Now it's like the future of AI because their GPUs are powering the future of AI. We need those GPUs to run all our compute-intensive algorithms, and it played out well. And yeah, really excited to be among this panel and discuss infra for AI.
Hi, my name is Christian Reilly, and I'm the founder of MedNition, Inc. We're a med tech startup helping, I guess the way I frame it is, we're by doctors, for doctors, and giving them the technology to help save lives. Basically, it's the 3rd leading cause of death in America is medical error, and so we just help docs recognize when they're tired or when they make a mistake, how in real time to stop, think, maybe change course, seek consultation. I want to thank, I did a bunch of startups, sold one to IBM. I want to thank Intel Capital for funding that one. Allowed me to take a couple years off and really think about what I wanted to do next, which was trying to help a really noble profession use artificial intelligence to improve the way that they approached clinical care and their patients. So I'll share my experiences. And I gotta confess, I'm a model parent. And I mean that in the model way, which is I basically babysit the development of thousands and thousands of building models and make sure that everyone gets better. Like we all try to do with our children, I'm doing that with modeling. I can't even count how many models we've generated over the last 3.5 years. But our challenge is, we have to do it with clinical grade accuracy because lives are at stake. And so the doctors that we work with have set some pretty high bars, and it's there. It's really there today.
So I'm Gus. I work for Google. I'm a software engineer at Google. I'm an engineering lead in something called TFX. So I'm sure all of you have heard of TensorFlow, probably. So TFX stands for TensorFlow Extended. So it's a machine learning platform that provides not only the trainer that most of us hear about usually. When we read in media, we say, this many flops and this many training instances processed, but also provides everything that is around the trainer, right? So the data ingestion, data validation, visualizations, debugging, statistics, etc. So before that, I was at Sybil, which was the most widely used, most widely deployed prediction platform at Google. And TFX is kind of a successor to that, and it's centered around TensorFlow. Several parts of TFX have been open sourced. You may have heard of TensorFlow Serving or TensorFlow Transform. So we hope to be able to, make a lot of the internal capabilities available externally as well, because this is a matter of evolving the entire ecosystem. Yeah, that's pretty much it.
Okay, great. So we'll start with the first question. So at first glance, during this discussion, there's this impression that we're entering this new and sophisticated AI era. But if we look at the maturity of a lot of AI-powered solutions in the market, we can see that the maturity level is really the level of custom craft. We have a lot of emerging applications, and there's still room for improvement in terms of their intelligence, in terms of their impact and performance. For AI technologies to really scale at the level that we discussed in this panel, they're going to have to evolve and mature. They also will need, arguably, a new infrastructure. When you think of the type of infrastructure that we will need, and in terms of the AI technologies like for NLP and for neural networks, what kind of infrastructure do you envision, and what will it look like? I'll start with Doug first.
Cool. So I guess we'll probably touch on a lot of things that happened in the first panel also. So data is kind of like most important, I think. So and the way that I feel, so thinking about an infrastructure, so at Uber and like a bunch of different places we deal with the world. So we actually don't know a lot about the world as it happens outside of computers. And so I think the most important thing is going to be to kind of augment, so the Internet of Things, so to augment that in a way in which we can actually make a smart usage of it. So right now we have a bunch of computing devices, but we can't really compute that well on them, at least in terms of AI, and we certainly don't interconnect them that well, and kind of like don't make a good use of what exists there. And honestly, there's not that much. So there's like phones that wander around, and they're cars, so we're embedded in that. There'll be things, but there's like not a lot in a lot of different areas. So it's been interesting talking about like what people do have started to build this out.
Yeah, and I want to extend that point, the custom craft part of it, right? So I was recently at a conference. I was having a really interesting discussion, and he asked me, how would you define intelligence? Like, why isn't AI intelligent, right? And my question back was, how would you define ability, right? It's generic, like ability to do what? Ability to run, I would pick cheetah. Like ability to fly, it's falcon, right? So the generic intelligence is, we are in a phase where AI, we need to define the problem before we try to define intelligence. And that's why the custom craft, it's going to go on for a while, is before, like humans are intelligent, but AI is not there yet, because we need to define, are we solving the driving problem? Are we solving the search problem? And then that's why I think it's unfair to say that, hey, why are we still custom building AI? It's more like we are building specific tools to solve problems. And once it's better than what it was 10 years ago, and it will be better 10 years from now. But I think generic intelligence is just, it's just, AI has gone through a couple of false starts in the last 25 years. I'm sure we agree. Like, people get really excited about, oh my God, AI is going to solve every single problem, and then boom, it just comes crashing down. And then, so I think this deep learning phase is picking up really well, and I hope it doesn't get crushed by people who don't know AI by making unreasonable assumptions. I'm sure you have thoughts on that.
I think about, Prateek, those kinds of questions all the time because I'm working in medicine where lives matter, and it's not so much AI today as it is machine learning, and so we look backwards to project forwards, and as a modeler, if we just throw everything in there, we can have unintended consequences with the models we build. And so if you put zip codes in as a feature, you're gonna have economic bias built into your predictions. And so we have to be careful that we have ways to sensitivity test the models we build. And that's generally, sort of industry related. In some industries you need more of that than others. And I think financial services has some challenges in the development of its models because it buckets everybody and puts them in spaces where they don't get opportunity just because they're part of a demographic, what we call a bin or a bucket. And so I think some of the big challenges that we face is actually testing what we build as models so that they meet a particular question that's appropriate for the industry and where it is in the industry. And I think, it goes all the way from regulated all the way, to just pure free-for-all consumer. And so in the regulated space, you need the bodies like, the American Medical Association to develop gold standards which AI models can be tested against. Because the last thing you want is some kid like I used to be and go develop a model that biases against sex or age or something and does a fairly good job and it gets deployed widely. And so I think that's some of the challenges we face. It's not so much, the compute power is pretty good today. I'd say I can build a 5-year business plan that puts me out at $500,000 a year supporting half of the US hospitals, and that same infrastructure would cost about $2 million in a 3-year period. So on-demand compute is there today to develop the models that are very specific to tasks. GPUs have done a great job of taking super compute intensive, particular areas like imaging, and sped that up so people can get stuff done overnight and get back and work in the morning and look at the results of a model against a gold standard and say, yes, we digressed, or yes, we got better. And then I hope, I hope that a bunch of startups come out with some really custom stuff that help specific problems like NLP, because just this conversation, it has lots of meaning and intonation, and if you were to feed the transcript of this into an AI model today, it couldn't pick up the nuance of all things that we have spoken. And that's where we need to get to in order to have truly good, highly accurate models that help people and predict.
Yeah, I agree, and I think it's true that a lot of improvements have been made in hardware that have enabled a lot of the ML revolution, with deep networks and whatnot. But there's a lot more to AI than deep networks, or ML. There's a lot more to ML than deep networks, right? So I think beyond GPUs, there is even more custom hardware that is special to ML itself. Tensor processing units, etc., are being made available via services, and I think we'll see more of this. But beyond just the raw processing power, I think managing data, figuring out what are ML best practices is something that is not very, the knowledge is not dispersed yet. So we have two options there. We can either educate, which is great, usually doesn't scale, or we can try to add a lot of these best practices in platforms that we build. So if I can build a data ingestion system and a debugging system and a model understanding system that leverages the knowledge of PhDs or software engineers, and it's packaged nicely, then I can give it to a startup that can apply it. Then this is really multiplicative, right? So I think this is an area we should be focusing on, because exactly AI is new, it's moving quickly, but I don't know if we have the background, the education, etc., to actually digest it. So we will, I think, very often trade off flexibility versus robustness. And I think over time what we come to realize is that you need flexibility in some very specific cases. Like let's say I want my modeling algorithm to be flexible. I want to swap a deep neural network with a wide network, or linear regression or logistic regression that many of us are familiar with. But I don't want my data processing pipeline to be super flexible because there's so many hidden pitfalls in there. So you want robustness in the pipeline, but flexibility in areas that allow you to better understand the model, explain why it predicted this way, say, with what confidence is this prediction being made.
To extend on top of that is when we really look at AI implementation. So when it's a generic algorithm, right? So it comes from CPU and then GPU, then it becomes an FPGA, and then when you're really sure you want to deploy, you go for ASIC. TPU obviously is an ASIC. So the problem is the flexibility versus speed, right? Like ASICs they can do one thing versus CPU, they can do many things, but it's really, really slow. So I guess the deployment question, the infra comes into picture where GPUs, like, what do we want to do, right? Like, can we just deploy a whole bunch of GPUs at the edge, meaning like any device, like a drone or a car? It's not possible. So it's more like defining your problem and making sure that you are at the right level where you are like, if you're not ready to deploy this in large scale, like just you better stick with like FPGAs or GPUs, or if you're still experimenting. But once you decide that this is the one thing that we want to do, then Google took a really good step and built TPUs. TPU is a machine learning specific ASIC, application specific integrated circuits. And tensor processing unit is definitely a fantastic step because people who use machine learning know that how painful it can be to just wait for a model to build so that you can deploy in production. There we go. Yeah, that's multiply that by like 10,000, and you know what engineers are doing in the past.
A lot of waiting.
Yeah. So yeah, that was just word at that point.
So I just want to address bad news for you. So in terms of like wondering when the deep learning thing will crash. So yes, it will. So like we're already on the way there. So I think it was referenced a little bit earlier. So everybody says AI, and so like deep learning has become semi-commoditized, well maybe entirely commoditized. So you go do a thing. So the hype has started over, I would argue it, your neck of the woods over at DeepMind essentially, and so like Deep RL is the next thing we're gonna go to. And so it's gonna crash down. And so I think it's actually been dancing around some of the things with the questions I thought were interesting to kind of like poke at the premises, and there's kind of like two of them. So one of them was the question was phrased like to, I think, or one of the things we were sent was like phrased how you make sure AI is just kind of seems to presuppose that there's like a thing that can be sent out. If we could just scale up the infrastructure, everybody would be happy. And I think that you brought out the key issue is that everything serves a purpose, and so there's no solution just works for everything. It's actually not it's not by accident that all the startups that you see a lot of the deep learning startups in the image space. So the thing that we have now, so this works very well in images. And so whenever you have a lot of different dimensions that can correlate into statistical regularities that are something you want to classify, this is great. So the thing that won't work is language, right? So we brought this up. So this is not going to work. Not at least initially because we can't know the nuance of what happened. It's simply because statistical correlations don't work for language.
And also, we were discussing earlier about how throwing money at the problem is also not, at least, okay, to take an example of how doubling the number of GPUs, it's not like as straightforward as if you have a cluster, you double the number of nodes, the runtime reduces in half. It's pretty straightforward. But when you're training, you double the number of GPUs, it's not linear, it's sublinear. Like you don't, if you use more GPUs, it reduces. So it's not, it also, you need more top of the line GPUs to make sure you gain that advantage, right?
Yeah, there's a more important issue though, right? So that we brought up before. Yeah. So, and again, that's it's not that we just need more GPUs that's going to happen. So actually. So, I mean, that's kind of like.
Uber has them, but anyway, yeah.
But you said you only use like. So you said,
that's right.
So we're talking about this, like, so to keep it on infrastructure. We don't actually need. So it's not the answer is not more GPUs. We have explored this at Uber, and it's not the answer. So, so I think it's interesting to look at the presupposition of the question. And so, like, my thing is, what do? We try and evolve the next state of AI. So, like, I obviously have a horse here that I'm trying to back, but essentially you're going to hit there's going to be a plateau here where you just can't do things. And so it's interesting. I went to a semantics conference and actually Yoshua Benjo was talking there. Also, he seems to talk a lot. And so it was interesting because he was in a room with formal semanticists. So I don't know if people spend a lot of time with formal linguists, probably not. So they deal a lot with trees. So like big trees, complicated structures. So language can be kind of like, you can create as much structure as you want on top of it, and if you're a deep learning person, you kind of ignore all that, and you throw it all in a big model, and you hit go. And so that'll get you some of the way there.
I'm a tree guy.
So
I have to be. Language.
This is the way to do it, I think. But it was interesting because the approach there will only take you so far, and so there's like a simple example that can be like in language. So negation scopes differently, so it depends on whether or not you negate just a verb or the entire sentence, you're going to do the wrong thing regardless. So if you just kind of throw everything into a bucket and hit go, you're never going to figure that out. And so deep learning thinks you can, but if you're going to bet on a thing, they won't, and so you should bet on the other thing that actually thinks about these things more deeply.
Okay.
We digressed.
Yes, I was that one way.
The lament
Try to go back to
of
infrastructure a little bit.
Should be the title of this presentation.
So you guys like went like
get us back on
the
track
question I had. Okay,
Yeah,
good. So I'll throw you guys to one. Okay, you guys are really smart, so we'll skip a couple of questions forward. We're going to talk about AI accelerators. So AI accelerators are an emerging class of computer systems designed to accelerate machine learning algorithms. So a lot of companies, Google and Facebook, are developing these new types of systems. Facebook has recently created the next generation GPU server, Big Basin. Do you believe that accessibility to these new high-performance AI computing systems and access to this specialized type of hardware is going to become a barrier for smaller organizations or startups as they compete with larger organizations in training the machine models to solve specific types of problems? So in healthcare, in transportation. What is your take on that?
So I can take a stab at this.
Anyway.
Yeah,
I was going to defer this to Gus.
It's up to anybody to go.
Yeah, so I think, no, it will not be a barrier for basically two reasons. So one is sort of from a technical perspective. A lot of these TPUs or custom hardware or ASICs or whatever are being made available as a service, right? So you can have the service model where you pay as you go kind of a deal. So a startup can probably afford that. But I think the most important one is not that. I think the most important is the reality is that you really need to have domain expertise of an area so that you can say, okay, how do I map this domain problem into something that can be solved by machine learning, right? And then you can apply machine learning. And then your domain expertise is applicable again to say, how will I create an experiment framework that will allow me to test, is this model better than this model? Or is this model better than my heuristic that I had when I started from? Because we all start with heuristics, right? Rule-based things, whatever, software. Then you kind of evolve it and you make it data-driven. So who will be able to design an experiment that will tell you if this is actually making the application better for your use case, right? So there's all these areas that are applicable. So you need the domain expertise, right? This is applicable to your area. So I do think that a lot of startups have this domain expertise and they could continue to do so. And the hope is that, by making technology available, open source or as a service, you can enable that. So I don't think it's a barrier.
And to complement what Gus said is, if you're a startup and you need 10,000 GPUs to run your thing, then you're not doing the right thing, right? You don't need that many GPUs or hardware in general on day one, right? You got to pick one problem, solve it really, really well, and to do that, you don't need hardware that Google or Uber might need, right? And that's really the trick, is to figure out that one problem, solve it, and then when you grow and you can afford And obviously, as you mentioned, it's commoditized. You can obviously rent it out. You can build your own stuff, and when you have the bandwidth to do it. So yeah, I don't think we are not going head-on against Google. If a startup goes against Google or Amazon to build its own infra, then you're not going to do it. They'll outspend you. They don't even need to be better, right? So yeah, that's my take.
Yeah, so essentially it's use and not power. So you've got to figure out, basically the marginal gain that you get out of using lots of GPUs is minimal compared to actually creating the right model and defining the problem in the first place. So it's not going to be the barrier to entry, essentially.
So I'm probably the only one up here who's seen the big box wars turn into the commodity server wars that turned into, I'm going to stack this up with virtualization and run it at 80%, consolidation wars to now, from my phone, I can launch a 64-core server with 416 gigs of memory in a cluster, and I can launch 100 of those from my freaking phone. So when I worked at IBM, I sold mainframes and power system servers, and I said, here's your 5-year payback. That doesn't exist. That whole world is dead. It just doesn't exist anymore. And so from an AI perspective, what that allows as a startup, it allows me instant access to what I need when I need it. And it's just like you said.
So the exception, though, is actually data. So the thing that actually drives the
you gotta
hardware
have data.
is data. Because you can't, so the cloud is super bad for data in a couple of ways. One is people generally don't put their data, but also it's super slow. So once you get into realms, so like we get a lot of data at Uber. We're about to explore getting more data at Uber because we're going to go into some video processing for self-driving. And so the amount of data that we have, you cannot store in a place that is not physically next to the thing that you're going to compute on. Otherwise, you will never compute on it. So it's actually interesting that the hardware, our biggest needs are by far data storage as opposed to compute.
And also the data thing, it's a very good point because I think in the previous panel, somebody mentioned if you're solving a vertical problem, right? Like companies like Uber or Facebook or Google, they need everything that's available. It's a big company, but once you define the vertical, the data that you collect, you don't need to store every single byte ever, right? And as you mentioned, once you define that, hey, I'm going to do some filtering at the edge. I'm going to put this thing on my drone, on my car to make sure that I don't waste millions of dollars just to store something that's completely useless. And once you figure it out, you don't need to waste all those dollars, and that's when your data set becomes valuable. Size is not the only thing that matters, right? It's more like, is it usable? Is it valuable? Is it something that maybe 10,000 other people can use, like your clients or customers?
You tried telling that to the regulators. You have a 7-year retention policy on medical records.
That's a whole.
Yeah,
go for it.
Yeah, no.
You deal with that more than most. Yeah, right.
Yeah, and something to add a little bit about data, right? So, we have evidence that the model performance or model effectiveness, if you will, is roughly, logarithmic compared to the data, right? So, more data makes it better, but not linearly so, right? So, again, data is important, but big data is not necessarily as important, right? So I think the most important part is how do you transform the data you have, whether small or big, whatever it is, into a problem statement. And how can I optimize this problem statement using machine learning, right? So I think that's kind of how we should be approaching this problem. And yeah.
So who in the audience is a modeler? We got no hands out there? Yeah. Okay, we got modelers. Okay. So just quick. It's 10 times more effort, 100 times more effort to prep the data than to model. Oh, God, yeah. Fair assessment, 100 times? Yeah. So when we talk about machine learning, what we're really talking about is managing really messy data. And that takes a lot of compute power. We haven't talked about how GPUs can help and GPUs can help processing and cleaning data, but when it's 80 to 90% of what you do, you don't see this. You can't go Google online. How do I accelerate cleaning data? But that's what we want.
Yeah, and the problem is that there's no fixed method, right? There's so many variables involved here. Like, let's consider just image data. Is it coming from a car? Is it coming from a drone flying over an agricultural land? Like, the way in which you have to pre-process the data, it's so different for each use case that a lot of data scientists just spend, as you mentioned, 80% of the time just, how do I convert this into something usable? The last 20% is building nice models. It can be a simple model SVM, it can be a recurrent neural network, but that's the last pretty part. The 80% is people, as you mentioned, people don't talk about it, but that's like the gory part of dealing with data.
This is like the unhype, unhype panel
non-sexy
here.
part of machine
Most of
learning.
it's cleaning data, and then you just
that's
hit
pretty
go,
much
and it's
all
like
we
kind
do
of
here.
works.
Yeah, that was my handle on Skype for like 3 years. Cleaning data.
So beyond the data scientists, actually, if you sort of look at the prediction platform, right, and you look at the code that goes into that. So how much of that is the trainer or the learner, what people are so excited about, and how much of the code base is actually everything else, stitching everything together, visualization, statistics, analysis. You will see that the vast majority of the code, and I'm talking vast majority of the code, is not the learner, right? So
It's like 6 lines of code to build a model. I got over 2 million lines of code to get there.
Right. So
And that's not including the packages that are, there's another couple million there.
so I think, I mean, there's a lot of sensationalization with AI and learning and this and that, but the reality is that there's a lot more to it, and that's where we should focus.
And also, one more thing to add is just to differentiate between training and inference, which is and it becomes especially relevant dealing with a lot of, as you mentioned, IoT, like edge devices. You cannot make them very expensive, right? Like when you have to deploy 10,000 sensors, you can't have $1 million sensor. That doesn't even make sense. And that's why to have low-cost sensors, you gotta, the trade-off is like how much data to send to the cloud, because the bandwidth is very expensive, right? If you don't want the bandwidth, to utilize the bandwidth, then you have to make the device expensive. That's another trade-off that we deal with all the time is how much to pre-process on the edge versus what to send to the cloud, and what processor, what hardware can we use at the edge. Like on the drone, do we use a Jetson, which is a combination of ARM and GPU, or do we need a Xilinx SoC system on a chip, which is a combination of say ARM and FPGAs. So it's different things are good at different computations, and it becomes very important when companies like Uber are collecting like shitload of data, right?
Actually, it's our own AI problem to try and figure out which data that we keep from things. So it's non-trivial.
Olga, when we were talking about the event, you had mentioned the concept of what's appropriate for mobile and stuff, but I don't recall the question. What was the question you had? It was how do mobile devices, and since we have Uber Labs, AI Labs here, it'd be interesting to see what you're thinking.
If you'd like to jump in, Christian,
I'm a back end guy. All back end processing, but
What's the question?
It's a good question. No, it's a good question. It was one of my backup questions.
No, the question is, I think you started off with
Prateek
startups
touched on it.
lose, like because of the hardware that large companies can afford. Will startups have a problem entering the domain? That was where we started, I think.
That's right. Yeah. Okay. Well, I'll skip to the. So just building on this concept of accessibility we've been talking about. By the way, I'm not checking my text messages. I'm actually looking at my notes. Just to make that clear. So technologies like Microsoft Cognitive Services, Google Cloud Vision, natural language APIs enable the use of complex AI abilities based on a simple API call. So this allows organizations to develop applications with their own AI capabilities without investing into and owning the necessary AI infrastructure, however you want to phrase that. So we're seeing more and more cloud-based AI solutions. Amazon Web Services now gives GPU instances. What is your take on cloud-based access to specialized machine learning hardware? Anybody?
Yes, please. Like TPU, please just productize this really soon. Because what we want here is just nobody wants to reinvent the wheel, at least not startups, right? Like so companies like Google, and it's a really good step, like building like really good machine learning oriented hardware that people can take advantage of, and yeah, like instead of us figuring out, okay, I'm going to start with this general purpose hardware and spend like a year building machine learning specific hardware, and then it's not even the main problem you're solving. You're solving like, how do I, reduce energy consumption, like that, right? And that's where big companies have the bandwidth to do that research and then deploy in production. So yeah, it's.
So I will say it is basically good. I will, not you specifically, but I've seen this from two sides. So there is a downside, right? So the downside is it's not your stuff, and it's somebody else is controlling it. And so I've seen this from two different angles now. So as a startup, it was just impossible. We couldn't go with the cloud because there was a disagreement with NVIDIA and other people about which GPUs to allow, and they only allowed things from 2 generations ago, and that's just not going to work. And so we were out of luck there, so we had to go with our own thing. Now, where I am now, I think somebody described us as not friends sometimes, and so being like on Google's platform is a thing that can go both ways, right? So the framework that have been released as open source is great, right? So it's not the greatest, and so you have to. So there is a give and take with that. So it's to get off the ground. We used it. You're in trouble though in some cases because it's going to lag behind the state of the art. So we actually hit the curve before you did, I guess, at Geometric. So you were saying you moved away from AWS because the pricing was not ideal.
Well, I'm not going to officially claim.
Okay, fine. I won't say that for you. I will say for us as a startup, it was not ideal, and so we had to move away from that. It was
pricing matters a lot for a startup, and the moment you realize that if you scale to like a terabyte scale, you're going to get burnt, then you got to figure out a way out of it. Yeah.
So you're in trouble. So. Right, I forget exactly what the question was also. there's a downside on this.
AI engineers like to talk and we forget the questions.
Well, look, Gus had to say something here because I feel bad for Gus.
So I will not touch on the hardware because we discussed extensively already. I think I'll touch on the other part of your question, which was these APIs are interesting because of the following. So they've taken care of a really hard part of ML, right? So they're taking care of the processes, the ML best practices in training the model, right? So you have a vision model that has been trained with good algorithms, with good amount of data by people that have, felt the pain of what it takes to build a model, how to improve it, etc. And then as a user, you have access to the product of it. Now, at the same time, images are also standard, right? So RGB means RGB, JPEG means JPEG, and our world has structure, right? So colors co-occur together, to your point earlier about statistics that coherent statistics allow you to learn. So our world has a structure. Some people have done the hard part of the training, and then you can use it. You can use sort of the fruit of the labor, if you will. So I do think that this for startups is very, very helpful. The sort of next step is to customize. So let's say the Google model or whatever, the Uber model can recognize 1,000 images, cats and dogs and whatever. But you want to recognize parts of a car or the parts of a chair, right? So the Google model won't say it's a leg of a chair. It might say it's a chair, but that's not what you need. So that's the next step where people have done a lot of work in doing the majority of the hard part of the work, and then you kind of customize it to your use case, right? And then at the opposite end of the spectrum is you use your own data to do the training, and that is tough. So my sense is that the first two are very easy to ramp up on. Very quickly you can do something amazing. The other is tough, but we're developing technology to get us there, right? And we're releasing it. And when I say we, I don't mean Google, I mean collectively. So there's a lot of work that is happening here, and it's made available.
Just to add a quick point to that is that how like a startup can create moat around what they're building is you take something that's already built, like for example, Google's model can recognize 1,000 different categories of images, right? But let's say if you are a fashion company where your user wants to know, is it a red polka dot dress? Then yeah, you take the dress classifier and build your domain expertise on top of that to build a vertical product, because you're not going to beat a big company in accuracy in recognizing whether it's a dress or a chair, right? So you take advantage of that, and I think like Newton said, you got to stand on the shoulder of giants and just do it, right? We have something available, just take that and build a meaningful product to build your own expertise. So yeah, that's, you were about to say something.
Yeah, that's prevalent in the open source community. So whether you take the Stanford models that are trained for just general natural language processing, and then you use your own data to tune them to be relevant in the medical community, that's available to everybody, for free download. That concept is widely available. It's encouraging to see that you've opened up the system to allow that customization of classifiers and subcategorization of classifiers to allow the advancement of basically, new technologies to come to market. That's great to hear.
Just not to steal your job, but we've seen the questions, so we just imagine like where we go. So one of the interesting parts you brought up is models. So this is actually a place that's going to be interesting. Whether or not models themselves are going, how much of a market for models there will be. So this has already started to happen. So it used to be in one of the frameworks that you had a model zoo you could like buy into. This, like how they got money. And actually this is the hard part. So we did take Google's models, spent a lot of time, it's like continually training for a year, 2 years, and so it's very good. And there are methods now to take a thing that recognizes 1,000 categories, kind of, specifically what you do is you kind of just chop off the part that does that, and you put on your own thing on the top, and you just hit go, and then it can figure out like the leg of a chair. And so it'll be interesting to see how that evolves. On the flip side, I think you brought up before, you do trade robustness for flexibility. So you are kind of out of luck if you don't actually want to recognize an image. So these things are not so useful anymore. And so that's also another thing you kind of trade with buying into the framework to do a thing well. So you get best practices, which is great if you're doing that, not if you're doing anything else.
Yeah, that's exactly. And also bear in mind that if you are using that model, there are 1,000 other people who will be using that, they will be taking advantage of that model. So you gotta differentiate yourself even more because, it's just the availability, right? If a big company open sources that model, then you're not the only person who's using that model, right?
All right, so this concludes our discussion for now, but we do have a question period, so we can take 1 or 2 questions. Najib.
Yesterday, Microsoft made an announcement about a new programming language for quantum computing. At the same time, exactly the same time, Bill Gates made a statement that he doesn't get what quantum computing does, even though he's very strong in math and physics. Is any one of you looking at how AI could be adopted or implemented in the new world of quantum computing?
I have a picture of a D-Wave CPU on my phone. But that doesn't qualify me. Go ahead. No,
it's just, I think the best part about quantum computing or quantum mechanics in general is that the existence of qubit. Just like how we deal with bits in computer science, right? 0 or 1, qubits will allow you more states, right? Which means the whole premise of quantum cryptography is based on that fact. So I think it's just adding intelligence. Quantum computing is still computing, right? Just like, say, cloud computing is just computing. When you add intelligence on top of that, you can do amazing things. So in this case, because AI is so compute intensive, it's very power hungry. Like how do we deal with 10 million images? Because either we add more hardware or we just devise better algorithms. Quantum computing allows that. It just adds another dimension. It's not just binary where we deal with 0 or 1. Each unit it can be 2 raised to 3, 2 raised to 4. Right? It can represent many states because of quantum superposition. I can go deep into that, but basically quantum mechanics allows each unit to be more flexible, which means it just adds more horsepower.
Yeah, so it's actually interesting within the context of AI because it's got the pluses and minuses of parallel computing to begin with. So it's like just more parallel now, right? So but it's also got the minus, which is nobody knew what to do with parallel computing. So it was all great. We had all these cores. So I think the thing that I liked the most that failed was the cell processor, right? So this seemed like a great idea, and it turned out that nobody could program it, so it kind of died. That was the thing that PlayStation PlayStation tried to push in PlayStation 3 to be everywhere. So I think it's interesting though. So eventually we got parallel computing to work and actually in this field. And so there will be something that will be able to leverage this. And so I don't know as much about the physical limitations about actually implementing your quantum computer in a way that you can use it. Yeah. But I do think eventually somebody will figure out the right way to leverage that for a purpose. Well.
Yeah, that's right. The implementation is still a pretty big question mark because
decades.
That's very unstable.
It's, unless you have some intelligence you want to share.
I don't have any, but I mean, my personal opinion here is that I don't think quantum computing will be the thing that democratizes machine learning and AI, right? I think education, best practices, systems, platforms, that's what will actually popularize it and make it more useful in the world. And surely at some point in time we will hit some barrier with, backpropagation, as Hinton said, or some other learning method. And then that's when quantum AI will kind of allow us to do the next leap or the next sort of kink in the rate of acceleration of how much we're making progress. But I don't think this is what you should bet. Don't hold your breath and proceed cautiously and focus on the 99% of what we need to do and only then look at the 1% that's 10 years from now or however long it is, I don't know. Yeah.
His thing. So the TPUs out of Google are super interesting. So we already touched on the difference between training and inference. And so what you actually need in production is inference, not training. So you don't need all of these GPUs. You might need TPUs. Don't know. You might need something else. But that's interesting. Once I keep looking at you, speak for all of Google. But once we're allowed to do the alpha, so they're trying to open it up to let other people do some stuff, and so that's what I'm interested in.
No, it's definitely hardware-wise. I would back Doug up here. It's just the TPU is it just sounds like another hardware launched by Google, but it's way more than that. It's just ML-specific ASICs. That says a lot. It's not yet another GPU architecture. It's not yet another ML-specific hardware. It's ASIC, which is they do one thing really, really well, and according to the claims, it's at least order of magnitude better than the best speed up that we can achieve with today's hardware. And that speed up goes a long way in building. A lot of deep learning or AI or machine learning involves experimentation, right? It's not, we don't know because there's so many parameters. So you experiment and then you figure out, oh, okay, this model works. To experiment, you need a lot of horsepower because you don't want to wait I waited 3 months for this model and whoops, it gave me 32% accuracy. Nobody cares, right? And so that's why this development is very important in TPU, is that it allows you to do experiments faster.
Okay. Well, thank you. We appreciate your. Well, this concludes our session today. I hope you found the two panel discussions interesting. Just want to remind you, you can check on our website. We have an event coming next week. It's about diversity. We hope you will join us, and thank you for coming tonight.